Greetings everyone and welcome. We continue with the functions. In this video today we have question 6. The graph of f is equals to minus x plus 2 and g at x is equals to minus x squared minus 4x plus 12 are drawn below. So we need to understand the kind of graph that we have. This is the f graph and this is the straight line. We have the g graph as the parabola. Let's just interpret the information given so that we can be able to answer the questions. The graphs intersect at B and Q. This is B and Q. There is a point of intersection of the two graphs. A and B are x-intercept of G. Here is the A and the B, the intercept of the parabola function. D is the turning point of G. Here is D, the turning point of the parabola. F and E are y-intercepts of F and G respectively. Here is the E, the y-intercept of the G graph. Here is F, the y-intercept of F, the straight line graph. Now that we have all the given information, we can move to the questions. The first question is 6.1. Determine the length of AB. So this is the length from A to B. To find this length, we'll need the coordinates of A and the coordinates of B. In 6.1, the coordinates are at the graph of G as minus x squared minus 4x plus 12. So we said A and B are x-intercepts. For x-intercepts, you always let y equals to 0. So this is the g at x as y. That will be 0 is equals to minus x squared minus 4x plus 12. We'll multiply the entire equation by -1, so it will be x squared plus 4x minus 12 is equals to 0. Factorizing the equation. So the factors of x squared, that will be x and x. Then we need the factors of -12. That can give 4 when we add or minus. The 6 and the 2. Then the 12 is negative and the 4 is positive. That simply means the 6 must be positive and the 2 must be negative. So positive 6, negative 2. X is equals to negative 6 or x is equals to 2. We now have the x-intercepts of A and B. We can now write the coordinates. The B is at where x is greater than 0. That will be 2 is 2, 0. Then the coordinates of A is negative 6 is 2, 0. The length of AB will be just the sum of the two. 2 plus 6 is equals to 8 units. That's its length. In 6.2, determine the length of FE. The length EF. E is the y-intercept of the parabola. So from the standard form, y is equals to ax squared plus bx plus c, whereby the c is the y-intercept. So now that you are given g as in this form, you don't have to calculate. The coordinates of E will be 0 is to 12. The y is equals to mx plus c in the straight line. The c is the y-intercept. The coordinates of f will be 0 is 2, 2. 6.2, the length of FE is not from the origin, will be the difference between 12 and 2, as it's not from the origin. That will give us 10 units. Moving on to 6.3, calculate the coordinates of the turning point D. This is 3 marks. This is D here, the turning point of the graph of G. Its G at x is equals to minus x squared minus 4x plus 12. So we need the x value and the y value at D. For the x value in the parabola, the formula you use is x is equals to minus b all over 2 times a. This is the formula you use to find the x value of the turning point in the parabola. Now substitute the values. We have the minus, the b is negative 4. So it's minus into brackets minus 4 over 2. So the a is the coefficient of the x squared. In this case is negative 1. X is equals to negative 2. You will therefore have to find the y value of the turning point. Simply just take the value of x and substitute it back to the original equation. G is 2 of negative 2. So that is minus into negative 2 all squared minus 4 into negative 2 plus 12. This is equals to 16. So therefore the coordinates of D, the turning point, x is negative 2, y is 16. Moving on to 6.4, determine the range of G. So the range is the y value of the graph. Graph of G is the parabola. You can see it turns at D. The y value at the turning point at 16. The graph is having the values of y below 16. Is below 16. So this is simply means y is an element of negative infinite to positive 16 with the square brackets. The graph have the point at D where y is 16. That's why we are including the 16 with the square brackets. Or you can just write it as y is less or equals to 16. 6.5, determine the average gradient of G between D and B. So we have D, the coordinates of D negative 2 is to 16 and the coordinates of B 2 is to 0. The gradient formula is M is equal to the change in y over change in x, y at D minus y at B over x at D minus. The substitutes, the y value at D is 16 minus 0 over minus 2 minus 2. Gradient is equals to negative 4. The last question of which is 6.6. Calculate the coordinates of Q. Q is the point of intersection together with B. So the graphs intersect at B and Q. Simply means to find the Q coordinates, we'll just say f at x is equals to g at x. The f at x is minus x plus 2 is equals to minus x squared minus 4x plus 12. Then from here we solve for x. Let's transpose this to the left hand side so that you can have the positive coefficient of x squared. So that will be x squared plus 4x the group minus x minus 12 plus 2 is equals to 0. X squared, 4x minus x is positive 3x, minus 12 plus 2 is minus 10. Then the factors of the equation, x and x, the factors of negative 10, that will give the difference of 3, or 5 and 2. So 5 times 2 is 10. The 10 is negative, then the 3 is positive. That must be negative, plus 5 minus 2. X is equals to negative 5, or x is equals to 2. We have two x values because the graph intersects twice at B and Q. The value of x at Q is negative 5. In the graph of F, we substitute negative 5, so we can find the y value. That will be positive 7. So the coordinates of Q, negative 5 is 2, 7. Please don't forget to subscribe. Thank you.